Alright, so this is 7.3 day 1. And we got a lot going on in this section. So for day 1, we're just going to be focusing on this right here, multiplying polynomials and factoring polynomials. Stuff that we've already done before, but now it's going to get a little bit more complicated. Days 2 and 3, we'll be doing some long division and synthetic division, and that will be exciting. So we've graphed polynomials, we've added and subtracted polynomials, and now it's time to multiply and factor them. So for multiplying polynomials, this is something that we know how to do. We're just foiling. It's no big deal. Alright, so I'm not even going to go over it. We distribute these guys here, we distribute these guys here, combine our like terms, and we're done. So we want to multiply and write the product as a polynomial and make sure that we have this in standard form. We know what standard form is. We've learned it from day 1. I've been stressing it the whole time. So here we're just going to distribute. Nice and easy. All 4 terms. So 2 times 4 is 8. X times x cubed is x to the 4th. 2x times negative 6x squared. So we get negative 12x cubed. Remember, we're adding our exponents when we multiply like bases. And we have 2 times 3 is 6. X times x is x squared. And we get negative 4x at the end. This is in standard form. We are good to go. Next problem. Feel free to pause at any time if you want to try these. What I'm going to do is I'm going to multiply these two together first. So foiling right there. We've got, I'm going to put that x minus 3 out front. We'll deal with that in a little bit. So I've got x squared, and I have x times 4 is 4x, and then we have negative 1 times x is negative x, so 4x and negative x gives me 3x. And then negative 1 times 4 gives me negative 4. That's foiling. That should be something that we know how to do. I don't need to take too much time doing it. Now what I'm going to do is I'm going to distribute the x to each part, and I'm going to distribute the negative 3 to each part. Alright, and I'm going to keep it really nice and organized off to the side here, and I would suggest you do the same. So my x times my x squared gives me x cubed. X times 3x gives me 3x squared. And x times negative 4 gives me negative 4x. Now for the negative 3, I get negative 3x squared. And what I'm going to do is I'm going to put that underneath the x squared here. So I'm basically putting all my like terms, organizing it nicely. Negative 3 times 3x gives me negative 9x, and negative 3 times negative 4 gives me positive 12. Notice how now I can add all these together. I have x cubed, and then here 3x squared and negative 3x squared. Those cancel, and I'm left with the negative 13x, and then I have the positive 12. So this is my final answer here, written in standard form. Alright, for the next one here, we have basically the same idea. Let me give us a little more space here to work. So for this one, I'm going to think of it as 2x minus 1 times 2x minus 1 times 2x minus 1. So I'm going to multiply those first couple together, and I end up with, I'll keep the 2x minus 1 out front, and I've got, well, 2 times 2 is 4x squared. I get negative 2x, and negative 2x gives me negative 4x. Then I have negative 1 times negative 1, which gives me positive 1. So now I'm going to multiply this 2x to all 3 parts of the trinomial. I'm going to have, so 2x times 4x gives me 8x cubed, so 2x times 4x squared. And then I have 2x times negative 4x, which gives me negative 8x squared. And then 2x times 1 gives me positive 2x. Next, I have the negative 1 times each part. And I have negative 1 times 4x squared gives me negative 4x squared. Negative 1 times negative 4x gives me positive 4x. And negative 1 times positive 1 gives me negative 1. Now I can add all these together. So I add vertically like I used to with just numbers, but now I have polynomials. So we have the 8x cubed. That just gets brought straight down. We get 8x cubed. Doesn't get added to anything. then I have negative 12x squared, positive 6x, and negative 1. So just added each part together. This would be my final answer. Alright, so factoring polynomials. We're going to go through three different methods. We have GCF, factor by grouping, and factor using quadratic form. Alright, so factoring out the GCF, we're looking for our greatest common factor. So in that first one, feel free to pause this at any time if you want to try the problems first. Otherwise, I'm going to go through explaining them. So for this first one, I'm going to take out an x, and I'm left with x squared minus 16x plus 64. Okay, but now this is not fully factored. I can finish factoring this part right here by using our AM method, or our reverse FOIL. I want to multiply to 64 and I want to add the negative 16. Well, that would be negative 8 and negative 8. So I'm going to have x times x minus 8, x minus 8. You know what's great about this? I now know, if I were to graph this, where my x-intercepts are. This can also be written as x times x minus 8. And if we remember back to yesterday, x minus 8 squared, that squared means that it just touches at positive 8 instead of going through. So let's try these next ones. If I'm going to factor this one here, I'm going to factor out an x, and I'm left with 2x squared plus 5x minus 12. And for this one, we want to do rainbow method. So let's do some rainbow method. We're going to multiply the 2 and the negative 12 to get me negative 24. So I have negative 24, and I want to multiply to 5. So those two numbers are going to be negative 3 and positive 8. So that x, this x right here, is just going to stay chilling out front. Don't worry about it. I'm going to worry about the inside for now. So I'm going to have 2x squared minus 3x plus 8x minus 12. I'm going to group it. And here I can take out an x, and I'm left with 2x minus 3. And here I can take out, let's see here, how about a 4? So I have 4, and I get 2x minus 3 left inside. So what I have here is x plus 4 and 2x minus 3. And do not forget about our little friend that was just hanging out in front. We're going to put that x out in front here. So we touch that up a little bit. We have x times x plus 4 times 2x minus 3. This would be our final answer, fully factored. Lots of work, but lots of fun. The last one here. First, I'm going to factor our GCF. So I'm going to factor out a 4, and it looks like I can also take out an x. So I'm left with x squared minus 100. Now, some of us might be thinking, ooh, I can also factor that x squared minus 100, and you're absolutely right. It's a difference of squares. So I have 4x times x minus 10, x plus 10. That's one of our quick ones that we can do. So we get x minus 10, x plus 10. You could also think about it as AM method, which you'd have negative 100, and our b, what we want to add to is 0, which would be negative 10 and positive 10 for our factors. So I like to think of it as difference of squares because it is faster. Alright, so we want to factor by grouping. This is kind of like what we did with rainbow method, but a little bit different. So we got these two here and these two here. I'm going to take out my GCF, so I get x squared, and I'm left with an x plus 6 in here. This next one, I'm going to take out a negative 5, and I'm left with x minus 6. I'm sorry, plus 6. So notice once again my same binomials. So I'm left with x squared minus 5 and x plus 6. Now some of you might be thinking, ooh, could I factor this because I see an x squared? And anytime you see like an x squared or like terms, think about factoring. But in this case, I cannot factor this any further. If it was like negative 25, I'd have a difference of squares, but it's not. So this is my final answer here. So once again, we're going to factor by grouping. However, you might be thinking, ooh, this looks a little bit funky. You're absolutely right. Let's put it in standard form, because you know we love standard form. So I get x cubed minus x squared plus 2x minus 2. Now let's group these bad boys. So I'm going to group these two and group these two. And I'm left with x squared times x minus 1 plus 2 times x minus 1. Again, we should be getting the same thing here and here. That's what we want. And I'm left with x squared plus 2 and x minus 1. Again, feel free to pause the video at any time. Feel free to skip ahead if you're like, hey, I got this factoring by grouping stuff, no big deal. Then skip ahead. All right, for this next one, we're going to be using something called U substitution. Now, we can make it look like a quadratic using U substitution, hence factoring using quadratic form. So what I'm going to do is I'm going to say that U equals x squared. So if I did that, well, x to the fourth, I could rewrite that as U squared, because x squared equals x to the fourth. Now you might want to rewind that and listen to that again because it seems kind of confusing. So what I'm going to do is I'm going to replace these all these. So I'm going to have u squared minus 4u plus 3. So we could factor this in our sleep. This is just AM method. So I want to multiply to 3 and I want to add to negative 4. Well, that would be negative 3 and negative 1. So I'm going to have u minus 3 times u minus 1. Now, remember, u equals x squared. So now what I can do is I can substitute back in x squared minus 3 and x squared minus 1. If you're good at this point, awesome. If not, pause it, rewind it, because there's one more step after this, but you got to understand this first part before we move on. Here I have x squared minus 1. I know that that's a difference of squares, and I'm sure that you do too. So we have x squared minus 3, and if I were to factor this, I would have x minus 1 times x plus 1. Both x squared and 1 are perfect squares, so we have a difference of squares, and we can factor it like this, and now we are done. 3 is not a perfect square, so we cannot factor that anymore. All right, same one. Try it, pause it, and then I'll do it for you guys. So I'm going to call x squared, or u equaling x squared. So I have u squared minus 9u plus 14. So that means I have u minus 7, u minus 2, because what multiplies to 14 and adds to negative 9 is negative 7 and negative 2. And then I plug my x squareds back in, so I get x squared minus 7, x squared minus 2. This one I cannot factor any further. It's not when you know when to stop, it's can you factor anymore. I cannot factor this one, so I'm done with that one. I can't factor this one, so I'm done with that one. And this is it. We're calling it a day on this problem. So we'll skip this slide. And here we go. Our homework is from the book. I know that's rough.